I never thought I'd witness something that would make me question everything I knew about the ocean until March 15, 2020, when our research vessel dropped anchor in the middle of the Red Sea. What we found down there, a mile beneath the surface, shouldn't exist according to every law of physics I'd learned in my 30 years of marine research. But there it was, staring back at us through the submersible's cameras like some impossible mirror reflecting our own disbelief. The morning started like any other deep-sea expedition. I was leading a team aboard the Ocean Explorer, a state-of-the-art research vessel equipped with the latest submersible technology. We'd been commissioned to survey the abyssal plains of the Red Sea, mapping the seafloor for potential mineral deposits. Nothing glamorous, just routine scientific work that pays the bills. The Red Sea in 2020 was still relatively unexplored in its deepest reaches, despite being one of the world's most traveled waterways above. Our submersible, christened Deep Echo, began its descent at dawn. The familiar routine of checking instruments, testing communications, and running through safety protocols felt almost meditative. As we dropped through the crystal-clear surface waters of the Red Sea, the familiar progression from turquoise to deep blue to black enveloped us. By the time we reached 800 meters, the last traces of sunlight had vanished, leaving us in the eternal darkness that defines the deep ocean. For 8 grueling hours, we scoured the abyssal plain methodically, our powerful LED arrays cutting through the blackness like lighthouse beams in a storm. The seafloor stretched endlessly in all directions, a barren lunar landscape of sediment and scattered rocks. No coral formations, no fish, no signs of life whatsoever. Just an underwater desert that seemed to mock our scientific ambitions with its emptiness. My colleague Sarah, monitoring the sonar readings, kept shaking her head. "It's like a graveyard down here," she muttered through the comm system. And she was right. The deep Red Sea felt different from other abyssal plains I'd explored. There was something unsettling about the silence, the way our lights seemed to get swallowed by the darkness just meters beyond our craft. We were about to abort the mission and begin our ascent when something caught my eye in the distance. At first, I thought it was a malfunction in our lighting system, the way shadows seemed to pool in an unnatural formation about 50 meters ahead. But as we adjusted course and moved closer, the shape became clearer, and my blood ran cold. There, spread across the seafloor like a dark mirror, was what appeared to be a perfectly circular lake. But we were already underwater, a mile beneath the Red Sea's surface. How could there be another body of water down here? The logical part of my brain screamed that this was impossible, but my eyes couldn't deny what they were seeing. The surface of this underwater lake was perfectly still, reflecting our submersible's lights like polished obsidian. Around its perimeter, what looked like a beach of white sediment created a distinct shoreline, and hanging above it all, a thick, murky fog that seemed to defy the ocean currents swirling around us. As we maneuvered closer, I noticed something that made my skin crawl. Scattered along the shoreline were dozens of fish corpses, perfectly preserved as if they'd died just moments ago. Crabs, eels, even what looked like a small shark, all lying motionless on that ghostly white beach. But here's what really disturbed me. Some of those bodies looked ancient, mummified by whatever conditions existed in this place. Sarah's voice crackled through the intercom, barely above a whisper. "Jim, are you seeing this? The water. It's moving differently." She was right. While the lake's surface remained mirror-smooth, we could see gentle, slow-motion waves lapping against the shore. It was hypnotic and terrifying at the same time, like watching a nightmare unfold in slow motion. But that wasn't even the strangest part. As we positioned our submersible directly above the lake's center, something extraordinary happened. Our craft, which should have descended smoothly into the water below, bounced off the surface like a rubber ball hitting concrete. The entire submersible shuddered from the impact, and for a moment I thought we'd struck some kind of solid barrier. That's when I realized we weren't looking at ordinary water. This lake was made of something far denser, far more alien than anything I'd encountered in 3 decades of deep-sea exploration. The density readings on our instruments were off the charts. This water was nearly 3 times heavier than the seawater surrounding it. If this has ever happened to you during a dive, drop "impossible" in the comments, because what we discovered next challenged everything marine scientists thought they knew about ocean chemistry and the origins of life itself. We spent the next 6 hours documenting this underwater phenomenon, taking water samples from the edges where the 2 types of water met. The boundary line was so distinct it looked like someone had drawn it with a ruler. Our chemical analysis revealed that this wasn't just water. It was a super-concentrated brine solution, saltier than anything found naturally on Earth's surface. But the mystery deepened when we discovered the source. Using our deep-penetrating sonar, we traced underground channels leading directly to this lake, fed by what appeared to be springs bubbling up from deep within the Earth's crust. Somehow, ancient salt deposits buried millions of years ago were being dissolved and pushed upward by geological forces we barely understood. The temperature readings were equally baffling. While the surrounding Red Sea water maintained its typical deep ocean chill of around 2 degrees Celsius, this brine lake registered at nearly 15 degrees warmer. It was like finding a hot tub in the middle of Antarctica, heated by some mysterious underground furnace. As we continued our investigation, I noticed movement along the shoreline that made me grab Sarah's arm in excitement. There, thriving in conditions that should have been absolutely lethal to any form of life, was an entire ecosystem unlike anything in our biology textbooks. Massive tube worms, bright green and alien-looking, stretched for hundreds of meters in every direction. Giant mussels, some easily over a century old based on their size, packed together so tightly they formed living reefs around the lake's perimeter. The diversity was staggering. Strange translucent shrimp, squat lobsters that looked like they belonged on another planet, and jellyfish-like creatures that pulsed with bioluminescent patterns. But most fascinating of all were the hagfish. These primitive, eel-like creatures seemed to patrol the water's edge like sentries. Unlike every other animal we observed, the hagfish showed no fear of the toxic brine. They would dive in and out of the deadly water with impunity, emerging with their prey, the unfortunate fish that had wandered too close and succumbed to what we later learned was called toxic shock. I watched in horrified fascination as a small eel, probably hunting for food in the area, accidentally crossed into the brine lake. Within seconds, it began convulsing violently, writhing in what was clearly agony as the extreme salinity overwhelmed its nervous system. The hagfish struck like lightning, dragging the paralyzed eel deeper into the toxic water, where it would become another addition to the underwater graveyard. This was nature at its most brutal and beautiful, an oasis of death that somehow sustained an abundance of life. The contradictions were mind-bending, and I knew we were witnessing something that would revolutionize our understanding of how life can exist in the most extreme environments on Earth. What I discovered at the bottom of that research tunnel would leave you speechless, because it suggested that everything we thought we knew about the origins of life might be completely wrong. After collecting samples and documenting the ecosystem for 12 hours, we finally began our ascent to the surface. But as the Red Sea's depths fell away beneath us, I couldn't stop thinking about what we'd found. Those bacterial colonies living in the mussels weren't just surviving without sunlight. They were thriving by converting methane, one of the most toxic gases on Earth, into food through a process called chemosynthesis. This discovery hit the scientific community like a tsunami. For over a century, we'd believed that all life on Earth ultimately depended on energy from the sun. Plants capture solar energy through photosynthesis, and everything else in the food chain feeds on those plants, directly or indirectly. Even deep ocean creatures were thought to survive on marine snow, the constant rain of dead organic matter drifting down from the sunlit surface waters. But here, in the pitch-black depths of the Red Sea, we'd found an entire ecosystem that operated on completely different principles. These organisms had learned to extract energy from chemicals seeping out of the Earth itself, creating a biological engine that could run independent of the sun's power. The implications were staggering. If life could exist in these conditions, extreme salinity, no oxygen, toxic gases, crushing pressure, and absolute darkness, then perhaps we'd been looking for extraterrestrial life in all the wrong places. Maybe the key to understanding how life began on Earth, and where it might exist elsewhere in the universe, lay not in sun-drenched tidal pools, but in these alien underwater worlds. Back at the surface, as we processed our samples and uploaded our data, I realized we'd stumbled onto something that connected directly to one of science's greatest mysteries. Geochemical evidence suggests that Earth's ancient oceans, roughly 4 billion years ago when life first appeared, were remarkably similar to the conditions we just documented: oxygen-poor, methane-rich, and extremely salty. Could these underwater lakes be windows into our planet's primordial past? Were we looking at the same type of environment where the very first living cells learned to harness chemical energy and begin their evolutionary journey toward complex life? The more I studied our findings, the more convinced I became that we'd discovered something profound. These brine pools weren't just biological curiosities. They were time machines, showing us how life might have conquered Earth's hostile early environment and suggesting where it might be conquering other worlds right now. Think about Europa, Jupiter's ice-covered moon, with its vast underground ocean. Or Enceladus, Saturn's mysterious satellite that shoots geysers of salty water into space through cracks in its frozen surface. Before our discovery in the Red Sea, scientists would have written off these worlds as too cold, too dark, and too chemically harsh to support life. But now we know that some of the most vibrant ecosystems on Earth exist in conditions that are remarkably similar to what we might find beneath the ice of those distant moons. If bacteria can thrive in the toxic brine pools of the Red Sea, converting methane into food and building complex communities in total darkness, who's to say similar processes aren't happening right now in the alien oceans of the outer solar system? The experience changed me fundamentally. Every time I look at the ocean now, I see it differently. Beneath those familiar waves that we surf and swim in, there's an entire universe of impossible places where life has found ways to exist that challenge our most basic assumptions about biology and chemistry. 6 months after our expedition, NASA announced that their upcoming Europa Clipper mission, scheduled to arrive at Jupiter's moon in 2030, would specifically search for chemosynthetic environments similar to what we discovered in the Red Sea. The underwater lakes that shouldn't exist had suddenly become humanity's best guide to finding life beyond Earth. But here's what keeps me awake at night, and what I think will fascinate anyone who's ever wondered about the true extent of life's adaptability. We've barely scratched the surface of what's down there. Those brine pools we explored represent just a tiny fraction of the Red Sea's deepest regions. Similar environments have been found in the Gulf of Mexico and the Mediterranean, each with their own unique ecosystems and chemical signatures. How many more impossible underwater worlds are waiting to be discovered? How many alien forms of life are thriving in Earth's own hidden depths, showing us possibilities for biology that we haven't even imagined yet? And if life can exist in these extreme conditions on our own planet, what unimaginable forms might it take in the vast oceans of distant worlds? The hagfish still haunt my dreams sometimes, those ancient, primitive creatures that seem to laugh at the toxic water that killed everything else. They've been patrolling those deadly shores for hundreds of millions of years, older than dinosaurs, older than trees, carrying secrets about life's resilience that we're only beginning to understand. If you've ever had an experience that completely changed how you see the world around you, drop "transformed" in the comments. Because that's exactly what happened to me in the depths of the Red Sea in 2020, when I discovered that the most impossible places on Earth might actually be the most important for understanding life itself. And if you want to dive deeper into the mysteries hidden beneath our oceans, make sure to subscribe, because we're just getting started exploring the impossible places where life finds a way. The next expedition leaves next month, and based on what we found in the Red Sea, I have a feeling we're about to rewrite the textbooks all over again.